Okay, this is the second part of our tangent cotangent. Didn't do the cotangent part yet, so we'll do it right now. Okay, so we should draw a parent graph of the cotangent so we know what we're dealing with. And you have your parent graphs. And the parent graph of the cotangent looks like this. Okay, and in degrees, this is the 0.90, and in radians, it's pi over 20. And this asymptote is that x is equal to 180 or x is equal to pi over 2. Or pardon me, pi. Again, the cycle length of the period length, cycle length, vertical asymptote, make a note there. The cotangent is pi. So if I'm going to calculate a period, I divide pi by b, or 180 by b. And we did this yesterday with the tangent graph, is that if you have a period change, you've calculated a new period based on this. Back with the sine and cosine, these numbers up top were either 2 pi or 360, but with tangent cotangent, it's pi or 180. Okay, so let's look at our first problem here, and it is number 19. And it's y is equal to 1/2 cotangent of 2x. All right, so we have an amplitude change and a period change. So we are going to, calculate that new period. I'm going to put it over here and then graph in this area. It worked pretty well yesterday. The period is equal to, and this one is going to be a degree problem, and we're going to go from negative 45 degrees to 90 degrees. Okay, so the period is 180 over 2, that number, which is 90 degrees. Half cycle then is 45 degrees, and quarter cycle is 22.5 degrees. And let's back up a little bit. The quarter cycle is important because on these graphs, we've got points that are at the quarter cycle of these graphs that are the reference points. So this point right here is at 45 degrees 1 on the parent graph, and this one is at 135 degrees, negative 1. And this is only one cycle. Keep that in mind. This thing is a periodic function. All right, so we're going to need this information when we start graphing. All right, if we go negative 45 to 90, we're going to have tick marks at 22.5. So we're going to need 2 to the left and 4 to the right. Okay. Now, the most difficult thing about the cotangent graph is what's the critical point? Now, there is no critical point. The critical feature, we call it, is the asymptote. All right, so that is what gets shifted. It's what was on the y-axis to begin with, and the y-axis is an asymptote for this, so we shift that asymptote. There's no shift on this one, but that's the critical feature. So the critical feature remains here, and we'll get to that when we have our second graph. I was getting ahead of myself there. All right, so that remains right where it is, the critical feature. All right. Now the period, of course, is 90 degrees, but the half cycle, 45, that's an important number here, because if you go to the right, you'll have an inflection point at a half cycle. And if you go to the left, you have an inflection point at a half cycle, which is 2 tick marks. Okay, so that's 45, 0, and this one is negative 45, 0. All right, again, just with the tangent, another half cycle, we get an asymptote. So here we have x is equal to 90 degrees as an asymptote. Now if you look at the shape of the cotangent graph, it does this. And again, we're going to draw the graph in, and then we're going to put the other points in. All right, since this is a vertical dilation of 1/2, here, that's going to be the point. Quarter cycle, 22.5, 1/2. So the scale, that's going to be 1. This point is adding 22.5 to 45, that'll be 67.5, negative 1/2. So the scale here is negative 1. All right, and over on this one, we're going to have a point here, and the graph is going to go through there like that, because it's going to mimic what happens on this half cycle over here on the left side of the asymptote. All right, so that point is negative 22.5, negative 1. All right, we'll check my grapher. Now you have to be careful how you put these in there. All right, we got the 0.5. We can do that. If it's a fraction that's not an easy decimal, you might have to put that in parentheses. Then multiply it. This has to go in parentheses. 1 divided by tan 2x. That's got to be grouped together. The cotangent. Okay. So let's set the window, which is, we said, from negative 45 to 90 with tick marks, 22.5. Y min, let's go say, we're looking at at 1 and negative 1 here, so we can go 2 to negative 2. Okay, and make sure we're in degrees. We are. Here's the graph. And that looks about right. Now, one thing I should caution you on is if you put the trace on and you try this point at 45, this graph will say there's nothing there. Now, we talked about that the other day when I was my first video on the tangent and cotangent parent graphs. That point's not going to show up on the cotangent. It's just what's going on internally to the calculator. We're not going to spend too much time on that. But these other points will. So if I try 67.5, I should get the proper value. If I try 22.5, I should get the proper value, which that's 2.5, 22.5. There we go. Okay. Problem number 2 is number 23. Our second problem is number 23, and it is y is equal to 3 cotangent x plus pi over 2. All right, this time we do not have a period change, so our period is going to end up being pi, because that's the period of a cotangent graph if it's not changed. We do have a shift, though. We should write this down. Half period is pi over 2, and quarter period is pi over 4. We do have a shift, and we find the shift by setting the argument equal to 0. X is equal to negative pi over 2. That's going to be the shift. All right, I should have put this down that this will be a radian problem, and we're going to go from negative pi to positive pi. Okay. So with our tick marks at pi over 4, we need 4 to the left, 4 to the right. Okay. Now that's what I was talking about a little bit earlier. We're going to shift that asymptote, pi over 2 units to the left. Okay, so I'm going to count over 1, 2, and this is going to be what's known as the critical asymptote. All right. Now we work off of that. with this information for inflection points and other asymptotes. Half a cycle is from the asymptote is an inflection point. So there's going to be an inflection point here and an inflection point there. If I go another half a cycle from here, I'll have another asymptote. So that one, and I should label these asymptotes. This is at x is equal to negative pi over 2. This one's going to be x is equal to positive pi over 2. Another half cycle is going to put me right at this inflection point. You have an inflection point every half cycle on these type of graphs. So that point is pi 0. This point is negative pi 0. All right, now the graph is going to pass through like that on the way down because it's a cotangent graph. Now to the right of the asymptote, we're going to have the part of the upper part of the graph. So this is going to come down from the top, and we're going to end right there. And to the left of the asymptote, like on this part of the graph, we're below the x-axis. Okay. All right, at the quarter cycles, pi over 4, we're going to be 1 unit. So let's say we have a point here, another point here, a point here, a point here at those quarter cycles. So that's 3 because of what we have here. So our scale, like on this one, looks like that. That's 3. Scale's 3. All right, so we can label these points. Quarter cycle from here, that's negative pi over 4, 3. This is positive pi over 4, 3. Okay, so from pi over 2, add a quarter cycle. That's 3 pi over 4, 3. And this one, quarter cycle that direction, is negative 3 pi over 4, negative 3. Okay. I'm going to check by graph. Okay, so again, we need 3 times, and this has to be in parentheses, 1 divided by the tan of x plus pi over 2. Make sure you close off all your parentheses. Okay, we are in radian mode. A window, negative pi to pi. Tick marks at pi over 4. Oops. I don't know what I did there. Maybe you saw that. No, I pushed, oh. Oops. I did it again. My apologies. I forgot to press the second function button. Missed it. Okay. Okay, so this is 3, 4, 5, 6, 7. Let's go to negative 7 to 7. All right, let's see what happens. Looks good. Okay. Again, these points, if I put the trace on, at 0 we're not going to see anything because that inflection point's not going to show up on the cotangent. At pi, we're not going to see anything because the inflection point doesn't show up on the cotangent. However, we should see this point, which is 3 pi over 4. And we do. We should see like that point, pi over 4. And we should get negative 3 there. And we do. All right, so everything's good. So similar to yesterday, we're going to go with problem number 20. And that one will be a degree problem. And the window will be negative 45 degrees to 90 degrees. Just like, it's very similar to the one we just did. Okay, number 20. 24 will be a radian problem. And just like yesterday, we're going to go from negative 3 pi over 4 to positive 5 pi over 4. Okay. So you should, it's going to be very similar to the one we just did, but the shift isn't quite the same. Okay. Until next time.